Liz is a business analyst for a global manufacturing company which uses IBM's Maximo asset management system to track and maintain its assets. During a recent manufacturing status meeting, it was noted production schedules were missed due to increasing downtimes. Liz has volunteered to investigate the increasing downtime using IBM's Watson Analytics. Her investigation began by exporting asset and sensor data from Maximo into a CSV file. She then accessed Watson Analytics, which is a cloud based service, and imported that same CSV file into Watson. Liz is going to utilize three of the components of Watson, the Explore, Predict, and Assemble view, to gain a greater understanding of downtime. So she's going to start by opening up her CSV file in Watson's Exploration component. And this component presents her immediately with a variety of questions or components that she may want to look at in more detail. So she has, again, not done anything other than import her CSV file into Watson. This question immediately draws her attention because she knows how focused her corporation is on cost. And as she opens it, her eye is immediately drawn to this red peak or spike, which is China, and it shows how much higher the maintenance cost for the assets in China are in relation to the other countries. And she could drill down on this. Maybe she needed to go down to the state level because there's multiple facilities in each country. And she can narrow down exactly where those costs are coming from. Again, from importing a simple CSV file. But she knows she needs to stay focused, and she's going to leave this aside for a minute and instead look at the downtime. And because she just saw that correlation to a geographical region, she's interested to see if something similar exists for downtime. And as she types in the words downtime and country, Watson again presents a number of things that she can look at, and this is what she's interested in. What's my total downtime by country? And as Watson presents the view for her, she can immediately read the graph, and it's telling her the darker areas, those in the darker shades of blue, have the highest amount of downtime. And Watson also presents some interesting information for her up top, but she wants to drill down a little bit more. Let me look at this same downtime, not by country, but by state. And again, I can see a geographical view. And now I can see and start to narrow down in that particular plant or facility within China. This is my highest amount of downtime. And again, I can drill down a little bit more. Maybe I want to look at the city and find that same information. As we continue to drill down into lower levels, Watson sometimes can't present the information a geographical view, so it gives me this information in a bar or a column chart so I can see that. And again, my eye immediately knows where the problem areas are. And if I don't like that particular graph, I can change to other components. But no matter what graph I choose in Watson, I know that Shenzhen has the highest amount of downtime. So I'm able to get this information in a minimal amount of time by simply importing that CSV file. Well, let's look at the predictive component of Watson. And Liz has preloaded this, and all her preloading involved was setting the particular target. So what is the target? Again, we're looking at downtime. So what this component of Watson is telling us is what are the influencers of downtime? This is the exact thing that she needs to find out. What are those components that impact downtime so that we can start to understand them and potentially take corrective action? Watson is going to tell you the top 5 influencers that you can see here. And I see things like asset and location. But she wants to look at all of the components to see if maybe there's something that isn't as expected, one of those data outliers that might help her understand downtime more. And she can scroll through each one of these, and they're ranked or shown or displayed in order. And all of a sudden, this one here draws Liz's attention: material flow. Well, Liz knows from years of working in the facility that they use three sensors on the plastic molding machines: material flow, mold temperature, and cavity pressure. And these sensors are used to monitor asset performance. But look here how material flow jumped out and is saying that if the material flow is watched, that can be a predictor of total downtime by 67%. So what does that mean? If all of a sudden we see material flow peak up or down, that can be an indicator of downtime by 67%. Well, Liz knows that this is huge, so she wants to understand this a little bit better. So down here is her material flow sensor. She has brought it in here to understand it as it impacts the whole influencers of downtime. And again, it repeats that 67% of the time material flow will indicate a downtime. But even more interesting, and it's such simple and easy language to understand in Watson, is it says that the interaction between material flow and installation date, which is how old my asset is, can predict downtime by 98%. This is huge. She now has the information that she can present to her colleagues in the next status meeting to show that the region of downtime, where it's occurring, and what the influencers of downtime are, the sensor data, specifically material flow and the age of the asset. So how can Liz present that information? She can present it to her colleagues in a dashboard view. The dashboard view is where she takes all her individual explorations, which we showed over here. She combines them with the predictive components. She can also add additional infographics. Infographics can be anything from her meter readings, or over here where we had different downtime and material costs. And she can present these dashboards and information to her colleagues in the meeting so everyone has a greater understanding of downtime by simply exporting asset and sensor data from Maximo into IBM Watson's cloud-based service. Thank you.